G'day guys, I'm Greg and this is my train room. This video is a bit of a different one. We've done a lot of updates and whatnot, but this one here is focused on a specific project. I finally bit the bullet and got myself some point motors for the throat and yard leading into the terminal here, and I decided to spend a week putting all this together. So installing the point motors, wiring up everything underneath, reprogramming my Mimic board, and then running trains. So this video goes through Monday to Friday, what I did each day, and yeah, I hope you enjoy. Okay, so now we're down here at the points, and the first step is obviously to install the point motors. I've got the Cobalt analog IP point motors. I've gone for analog as going forward. I think all my points and signals will be won't be DCC controlled. I'll say I want to develop the hardware or the software to control them, and then the position and the status of signals and points will eventually feed back into a JMRI or a train controller type thing to control the train. So basically, I'll set the points and I'll set the signals, and the trains will drive themselves rather than a computer setting the points and the signals. Yep, so that's why I've gone for the analog. So install these, very easy. They come with a double-sided foam sticky pad. So one side you stick onto the top of the motor there, and then the other side onto the baseboard. And then you've also got the notches to then screw it in later, which once all the points are in, I'll lay this table over and screw them in. So the better thing to do when installing points is to install the point motors at the same time. Basically mark out where the point's going to be, drill the hole for the point motor, and then install it all. I didn't have these point motors when I was installing this, and I was just too keen to get in and lay track. So I figured I'd work it out when I got there. And I'm here now, so I've got to work it out. I've already installed most of the points, and I think I've worked out what I'm doing. So I have used a reasonably sized drill bit. I should tell you what size it is. So I've used a 3.5mm drill bit to drill a small hole next to the point when the point is in, well, on this side, the point's furthest that way, so sort of as close as I can get to there. And then on this side, I've thrown the point this way and drilled in a hole on this side. And then, using my little off-brand Dremel tool, I've got a bit on here that is used for carving something. I'm not exactly sure what. There we go. It's probably not designed for this, but it does the job. So basically what I do is I come up from underneath into the hole and then push across towards a point, but below the level of the point, to carve out the rest of the MDF. Rightio, so the battery on my rechargeable Dremel tool was dead, which makes sense. This is not the first one I've done. I've done 1, 2, 3, 4, 5, 6, 7 already. Yeah, so that was all this morning, and I've come back tonight to finish it off, and yeah, it's dead. But while it was charging, I watched back the previous clip and realised that you watching me Dremel out is not the most exciting thing. It's just me staring at the board. So we'll skip that bit of footage and come straight to, I've now finished Dremeling out this hole here. Basically, you have to go until you can poke the rodding through the hole in both positions. So like that. Beautiful. That's now that. Now we can install our point motor. We're going to chuck on one of these pads on this side. And to install our little point rods here. There we go, a little screw that it's got a big flat top and basically holds on. So this goes in a little spot there, big little screw on top. And if I grab my little screwdriver, found it. How often do you guys just put things down and like swear you saw them 2 minutes ago and they're just gone? So it's important to have a clean training room and a spot to do your working rather than on the layout itself. But when you squeeze into space, you got to use all the flat surfaces you can. And then you've got this little piece here, which basically creates a fulcrum for the point rodding to twist around. These motors come pre-centered, so that point motor is in the center, and I have not. Once you start putting power to it, I have no idea how to recenter it. So don't put power into it until it's in place. And what you want to do is you want to sort of try and center the points, and these points still have their springs in them. I think I'll take them out later, but for now I'm going to leave them in there. So what I do is take up a bit of old Whippix box and squeeze them in there to get it sort of roughly centered. This does have a lot of play in it. Then what we're doing is we're coming up from the underneath, feeding it, there we go, through the hole. And now before you, I know you can't see what's going on underneath, now before you push it up and push it on, you want to make sure that it's square this way, so looking from the side and making sure that it's not leaning forward or backwards too much. And then when you're sort of happy with the placement that way, you want to look under the board and make sure you're square this way so that when it does throw, it is going both ways fully. So I'll be right back. There we go. That is now on there. A little push. As simple as that. I'll take these out. And yeah, it's holding it pretty well in the middle there, which is good. So eventually you'll come back and cut this down, but I will wait until it's all working before I do that, just in case, touch wood that I don't have to, but just in case I have to remove something or relocate, or who knows what happens. So that'll stay up until I know all the points work how I want them to work. So I will go ahead and install this other one underneath here, and then I do have to install another one down this end, down that end. One issue with using the Dremel tool is it does create a bit of heat, and unfortunately I managed to melt the end of one of the throw bars. So now I'm going to have to work out how to attach the rod. I could go the other side, but I'm actually in quite a tight spot there with the other point motors around. It's actually the double slip. So when I work out how I'm going to fix that, I will show you that one as well. But yes, that's today done. Tomorrow will be all the wiring up of the hardware. So we've got our relay board from the Arduino, which I will discuss a bit more, and that will then feed to more relays, which will then control the points. But yeah, we'll come back tomorrow and get into that one. Cheers. So day 2 has me soldering, a lot of soldering. This is the day where I focused on basically the wiring hardware. We've got our positive and negative inputs for our 12 volt. 12 volt powers these relays and these relays. Double relays, bit of overkill, but I'll get back to that. And then we're going to have our 6 inputs from the Arduino, which will be the 6 different point pairs slash triplets slash singles. Again, I'll get to how the points are all wired together in a later video. This feeds into, sorry about that. Yeah, so these lead into this board here, which is an Arduino compatible relay board. Basically, the issue is the Arduino 5 volt doesn't provide much power in terms of number of amps an Arduino could put out. So an Arduino might be able to run 1 or 2 relays, but really this is what you need. I imagine there's a bunch of transistors in here to activate when the Arduino signal comes through, which then use the 12 volt supply to throw the relays. These relays are then connected. I'll show you up if I move this one here out of the way, you should be able to see. These relays are connected with a common in the middle, and normally closed and normally open. So what I've done is I've run the 12 volt. I should say the 12 volt comes in to here. This is basically a 12 volt common rail, and this is a ground common rail. So it comes into here and then back around and then into the first relay here, and then just daisy chains to the common terminals of each of the relays. And then from the normally open terminal, we come to our other relays. Basically, these relays are only single pole double throw, and these ones are our double pole, well, there's actually quad, so double pole quad throw, using as a double throw, just using the 2 left ones here. Again, these are overkill, but I have a bunch of these in stock. Well, I have 5 of them in stock, so I've used these for now. Yeah, so these, when this relay is activated, we get a connection to our 12 volt, comes through this green wire here and creates a connection across this relay back into ground, and so this relay becomes active. And then from there, we've got a connection between this ground pin and this pin here, and then a connection from this pin here and our 12 volt. Basically, to run the cobalt point motors, you need to run 12 volts, and depending on which polarity you have that round determines which way throws the point motor. So our 12 volt comes in and then comes through this side. I'm going to get it wrong here. I'm actually not sure which way around it is, but that doesn't matter. One side is normally open and one side is normally closed. Basically, if this side's powered, it's going to power the opposite ones on this side, which will then go off to other headers up here, which will go to the point motors. So if, let's say, this side is powered, it will reverse the polarity, so we'll have a 12 volt here and a negative here off to the point motor. If the relay's then thrown and the power's coming through here, we will have 12 volt on this side and a negative on this side going to the point motor. What this means is that whenever the power is off, as in the Arduino isn't sending a signal, there will still always be power to the point motors, which will mean that they will always be set to a normal position. It's basically a fail-safe thing. If the fail-safe idea, I won't say, if the Arduino fails, all the points will be set to the normal position, and I've got to determine which way I want the normal to be, and then it goes to the reverse position if we get power. Same thing. One benefit of having these extra switches here is these could also then power maybe some dwarf signals or other signals. They would then have the same thing. I'd have it powered up so that normally closed would always provide a red, and then it would only change if power was provided, and that way if we lose power, technically everything runs safe because all the lights are then red. But yes, that's that. I've fully wired up these ones here. They are a bit of a mess. This one here was originally wired up for the previous motors I had there, and I used just small bits of wire to do these crisscrosses. But I had some bare, what's this, tin copper wire, which is quite strong, and I decided to use that to make the crosses. Basically, there's a small gap between, there you go, there's enough gap to get my tweezers inside there, so there's a small gap between them. Just saves on wire, saves on stripping and all that type of stuff, and yeah, so they're all like that. Eventual plan for this will be a PCB of some sort. Just thinking about it too, I've realized I could sort of remove these relays, because these are all 12-volt relays, and take whatever powers them and run that directly to here. Which, yeah, is something I'll do if I can't design a complete system. Will be, yeah, hijack one of these boards. Unfortunately, they're not cheap, so I don't want to pull them apart too much. But that might be a simple option rather than sort of double relaying it out. Just, yeah, take 2 wires off here, throw into here. Bob is your uncle. But yeah, I'll crack on, finish soldering up tonight, and tomorrow will be programming. We'll chat to you then. So now that basically all the hardware is done, it's time to start planning the routes and then getting that into the software, the Arduino program. So basically we have, I should know, I think it's 11 points, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 points to control. Now, instead of controlling each one individually, some have to be controlled together. You can't use one without the other. For example, this crossover up here, there's no point throwing this switch to the diverging route without also having this switch on the diverging route. So it just makes sense to control these points here off the same feed, or the same command, I'll say. So that is very simple. That one there is going to be 2-point motors controlled by one output. And then getting in here is where the planning needs to occur in terms of what routes should always be thrown together. Sorry, what points should be thrown together, and then what points need to be thrown for what routes. Basically, we've got 5 routes in, from the up to the platform 1, 2, 3, 4, and then the relief in the middle, and then 5 routes out, again, in the down on that side. So, having a look here, there we go, I'll take my shadow out of the shot there. Basically, this point here is by itself, because either you're going straight through or you're going to the single slip. That's a very simple one to plan. The single slip is interesting because a train coming on this path here, it doesn't matter which way the slip's thrown, it can always enter from this direction, and just depending on which way the switch is thrown, sends it straight or turns left. Similarly, from this side, from platform 2, again, doesn't matter which way the switch is thrown, you can never run, I suppose, against the switch. So in saying that, this point here, if this one's thrown, this point here needs to be thrown in the correct direction, otherwise you will be running against it. So this one here and the left-hand side of the single slip need to be thrown together. And then it gets a bit trickier. I'm actually going to jump up to these ones here, and I'll come back to this. So again, the one into the relief is very simple. It's just going to be 1, because you're either going on platform 4 or into the relief. I'm going to call these 2 here as a crossover, because, yeah, if you're, sorry, I'll take that out, there we go. If you're coming from platform 4, not that you would really ever, because if you're coming from platform 4, you're going straight. Oh, that gives you more to think about. But basically, there we go. Actually, yeah, if you're coming up, you're either going platform 3 or platform 4 or the relief. But if you're diverging, this one here needs to be thrown to accept you, basically. So I'm going to pair these two together. And then down here, basically this one here is always looking at a point that can be thrown against it. So this one here, if it's diverging, we're going to this one here in the normal position, or if we're in the normal position here, we're going the single slip needs to be thrown so that it can go straight through. So this one here is actually tied to 2, and I'm going to tie it to both of those. It will mean that, throwing this one here will also throw this one here, which is probably a bit of a waste of a movement, but I think that keeps the wiring simpler as well. So I'm happy for that to remain like that. But what it does mean is, because technically this one here could be tied to this one up here, because if this one's diverging, you could be going to the normal throw of this one here. And I thought, oh, okay, I can tie them all together, but then that doesn't work, because if this one is set to, if this one's set to straight, it would set this one to straight. And if this one's set to diverging, it would set this one to normal. But this one's normal, this one wants to be diverging because they won't be opposite. So I hope that makes sense. Basically, yeah, these two, if you're coming in the normal running out of platform 4 or the relief, these will be 2 separately thrown switches, which probably makes sense because they're that far apart that you would have time to sort of stop here and wait if, for whatever reason, that one there isn't thrown. So we're treating this section here as a, I suppose, a decent section of track that you could shunt within, I suppose. So there's the other way to think about it there. So yeah, so counting up, we will have 1, 2, 3, 4, 5, 6 individual commands to control with the Arduino. So this is the code for my current setup, and basically all I'm doing is adding in an extra line that first of all turns the lights a different color. I went with blue. You can go like an in-between color, but because it's RGB, just the nice blue just stands out rather than trying to mix. Like I tried to go like orange, but it just didn't look good, so I just went straight with blue. So basically it'll turn the light blue, and then it goes and throws all the points, and then it'll turn the lights green along the route. Yeah, I won't get too much into this. If people are interested in this code, it is very straightforward. I have minimal programming experience. Literally, I only program Arduinos. I found myself a good book. But if people are interested, I'm happy to do another video to sort of step through this and sort of just show like sort of the steps I took to slowly make it more and more complex and actually do what I need to do. So yeah, let me know if that's something you want to see. It's not the best code. I'm sure it could be optimized more, but it does the job for me. And yeah, maybe one day I'll slowly work on it and get it more refined. As with the rest of this layout, it is all about learning, and yeah. Rightio, we're up to Thursday. Tracking along pretty well. This is my soldering station setup. It's been good just having the solder out. I find I don't like soldering just because I keep it all in a little briefcase here so I can move it around the train room. But it's always a pain to get out. But being able to leave it set up here with the flux and the solder and the soldering iron and the cables and the cable cutters and just everything there ready to go has meant if I need to solder something, I can do it quickly. I can just pop over, turn it on, leave it 5 minutes, solder, duck away again. So going ahead, when I get my own train room, I think having a solder station permanently set up will be the go. I just want to show you, I have the first light on the panel, which is very exciting. That's just the 12-volt power light. Basically what I've done is I've taken time to install my power feed. So this is like I showed in the previous video, just an RCA cable.
with the common ground and then a positive and a common ground and then a positive and a negative. Oh, I did it again. Let's try that again. We've got the common ground, and then we've got a 5 volt and a 12 volt feed coming from our computer power supply. I've got one at that end, and now I've got one at this end feeding onto this board here, feeding into a terminal strip which will be mounted up here, and then feeding into the 12 volt side of this relay board. So next step tonight after work will be running all the wires from the point motors into this terminal strip here. Basically, now that I've got 12 volts onto here, that will mean that I'll be able to set all the points to normal position and hold them there. That'll take a little bit of fiddling, make sure all the right wires are the correct way around. And then I've got to set up the connections from the Arduino into here. So I'll be back with you after work. Righto guys, it's Thursday night, so got an hour or so tonight and then some time tomorrow to try and finish off this project. I think I'm pretty close. Very exciting times, just it's been really cool just sort of focusing at radio, just sort of focusing and saying radio, I'm going to get it done. So tonight my aim is to finish off the wiring. I did a little bit of software stuff last night, but I've got to do some wiring now to finish that off to know where everything's going. And this is probably the part I'm looking the least forward to, because basically I've got to get back under here. By under here I mean turn on the side and deal with it that way. And then connect up all the point motors with the little fiddly inputs they have. A lot of stripping of wires and whatnot, and then hoping that my placement has all worked and these all actually throw across, because as soon as I find out that some of these don't work, I'm going to be very sad. But what I've done is I've tried to be real fancy. I've got myself some cable, some old like 6-core cable, taken off the outer sheathing, paired them up, and then wound them into spirals just to make them a bit neater when I come to organising under there. So I will install these now, grouping together all the different point motors, and then basically doing a test on each group just to see which way the normal position is. So wish me luck. I will come back to you when this is done and it's all working hunky-dory, hopefully. Rightio, it's Friday night and all of the wiring is done. Well, I'll say almost all the wiring is done. I haven't wired up this switch here because when I was drilling it out, it got a bit hot and I managed to break the little hole that receives the wire. I could drill a hole on this side instead and put it on this side, but then we're getting very close to this point motor here. So I've super glued a little bit of plastic card here, hoping that works, but I'm not touching that for the time being. I'm wiring everything else and seeing if it works. I'll come back to that one. So showing how I've connected to the panel here. Using these jumper cables with all the same colors. These colors then match all the colors that are coming out. So basically, if it's brown in here, it'll be brown out here, and that helps me follow everything along. It looks a bit loose. I think that is loose. It'll do. Actually, no, it won't. I'll fix that one up. Anyhow, and then similarly, I've used these same cables under here to connect from the Arduino out, and then roughly matched. So basically, whatever color the Arduino is talking to, it is talking to the exact same relay here. So I'm using that to make sure that everything falls in line. I was right when I said I would hate putting all these in. I think almost all of them I didn't get around the right way first time and had to fiddle with it and switch them around, and they're just not the greatest little pins to play with. But anyhow, That's all good to go. I'm about to start or finish off the programming, and yeah. This is how this used to be mounted. I don't like it anymore. I will put this on a drawer slide, but that's woodworking. That's a different video, I think. So I reckon come back tomorrow. This will be done, and I'll show you it all. So thanks for watching, guys. I hope that video was entertaining. Maybe you learned something. Maybe gave you some ideas on what to do in your own layouts. Obviously, I'm not going to leave it there. I will finish off this video with a shot of the train running through this new section. Very, very exciting stuff. You may have seen, you will see, sorry, I should say, in the next clip, what's coming up in the next video. And that will be some landscaping. Very excited to get into that, make this end a bit more of a scene. So stay tuned for the next video, and I'll see you then. Catch ya.